times. Okay. There we go. I'll fill these up about halfway with cabbage juice so you get to see a good reaction. It's just cabbage juice, that's all it is. Well, it doesn't do anything right away, but in the cabbage there's these compounds. Have you guys heard of antioxidants and that kind of thing? What do they tell you about antioxidants? They're good for you. And actually what gives the red cabbage that purple color are these antioxidants. They call them phytocyanids. And what happens is if they react with one of these H plus molecules, they'll undergo a change. So H plus plus, we'll just call it, I'll call it PC for phytocyanin, will go to H phytocyanin plus. That the hydrogen will combine with it, it changes the compound, and the change in that structure makes it undergo a color change. So let's take a look at that.
Is that the same stuff as yesterday?
Yesterday? No. This is, oh yeah, that stuff I poured in for the hydrolysis of water. So which same stuff is this?
Yeah, when we were doing the little
Acetic acid.
Oh yeah, I'm sorry, this is the acetic acid. It's essentially vinegar. So let's check this one out just for fun and let's see what it does. So you can see right away there's a color change, see that? And so the acetic acid, this is what you should see with an acid. The acetic acid is a weaker acid. We could take a stronger acid, we'll probably see a more red color. I can use that with, I have actually hydrochloric acid here. So the hydrochloric acid, I'll just pour some in. So much less, it was just a few drops, but you'll notice I get quite a brighter red color. See that? There's 3 or 4 phytocyanids. There's one that has a blue color, one that has a red color like you're seeing, and I think there's a green one. And so the pH depends on which cyanins are changing into what color form. So there's your acidic with your acetic acid. And I think I only had one, so we can play the game. Oh, let's do the base. Let's do the base first. Let's look at something basic. So here on the base side, I have sodium hydroxide. So we can see what that looks like. And so this is a typical situation with a base. So you see that green color? Cabbage juice turns. I think the bleach, this one's kind of interesting. If you guys do the bleach, let's see if I can get some bleach out there. Can't see it. There we go. All right. The bleach will actually not just have a pH, it's a basic solution, but also have an oxidizing effect. So it actually will, it destroys the phytocyanids. You get a clear solution. But it is a basic solution. If you added a small amount, you could see that. So that's kind of fun. So then we can play the game. We can take pine salt and we can guess acid or base. So you kind of have a range here. You got like, okay, here's really acidic, here's kind of acidic. The cabbage juice should be pretty close to neutral. And then our sodium hydroxide. Those are kind of our common color changes. So you guys, you want to try pine salt? What do you think?
Yeah.
What do you think? Take a guess. You have to guess. That's part of the game. Base. Okay, let's check it out. You guys are right. Not as strong of a base as the sodium hydroxide, though, right? Okay. But that's the kind of idea. I'm kind of eyeballing. I'm adding, equal volumes of cabbage juice and the compound I want to test. Were there any other? You guys, nobody else? I mean, you probably didn't want to carry a Comet in your backpack, right? That's probably why you didn't bring your house for chemical. But if you wanted to test one of these, you could do these at home. We'll look at pH when we take Chem 22. So I hope you guys enjoy that demo. This was just a short one. We'll go on to the next thing. So